Hi everybody, Amanda here from Realise Beauty, and I want to update you on my Oleogel balm squishing experiment that I started last week. Just to recap, this is an experiment or set of experiments where I'm looking at a particular Oleogel formula. As I said last week, the formula itself is not that important. What's important about it is it's an oil and wax combination that forms what we call an oleogel, which is somewhat between a liquid and a solid. It's kind of like a soft solid or a hard liquid in terms of a formula, and it's very common used in cosmetics for your balms and butters and that kind of thing. So something like a lip balm would be an oleogel formula. So what I'm trying to do in this experiment is find out how much you can squish it, so how much force it takes to squish it. And I'm doing that in a very particular way, using a force meter and pushing something, or pushing a little probe into the product until it gets 2/3 of the way down. That's important because if I go all the way through, there's a chance that I'll hit the bottom of the container or the test stand, and that will give me a false reading. So I'm always pressing into the product only and making sure there's product all around it. So I'm getting a maximum force reading, and that's what I'm interested in for this set of experiments. Now, what I've been doing over the last week is lots and lots and lots of repetition. So I have had little questions within questions to find out if the packaging that I use affects the balm strength. So I've tested the balm naked, and I've tested the balm in glass, plastic, cardboard, and metal. Yeah, so I've tested it in 4 different types of containers. I've done a few other things around that as well, but they're my main things. And this is what I'm finding. So far I'm finding that the best way to test the naked balm is to turn it into a cylinder shape. So it's kind of like what you'd get if you took one of the cardboard tubes and popped the inners out, and then what I'm doing is cutting that in half essentially. So I'm making myself a little wax cylinder, and then I'm compressing that or pressing that without it having any packaging, and that's giving me my just the oleogel strength on its own. Then what I'm doing is comparing that value to what happens when I put the product in packaging, so these different types of packaging. Now, in order to make that data comparable so that I can actually be comparing what they call apples with apples, I suppose, or the same amount of product, whatever, I'm taking the figures that I'm getting in newtons, which is just the force irrespective of what it's pressing into, and I'm converting it to a unit called kilopascals, which will then tell me the amount of force as a proportion of the volume, like in relation, to the volume of product, so that all of the data, regardless on the packaging size and shape and whatever, is somewhat comparable. So it's ironing that out. So when I do that, I'm finding that the cardboard and the metal containers are increasing the strength, so it takes more force to press down to that 2/3 when I package this in card or metal. The cardboard was giving me 12 and a bit % improvement in strength. The metal was giving me just under 9%. Interestingly, the plastic container that I looked at gave me a rise in strength of around 58.5%, which is huge. So I really want to dig more into that, have a chat to some different people who have more experience in packaging of these sort of products, and see if that's typical or whether I've got some weird thing happening. Another interesting thing that I found is that when I packaged the balm in glass, the 2/3 squish gave me a much lower value. So instead, I got a value that was 21.5% below what I started with. So packaging this oleogel in a glass container was making it weaker. I think so far this information, this data is interesting. I'm not convinced yet that I fully understand why, although I do have my theories regarding the different types of material that's used and all the rest of it. Now there's a lot more data and a lot more things that I've considered than I'm going to share in this video because I don't want to bore you, but one important thing to note is just how many times it takes to do the experiments each time, and how I make sure that my results are sensible, that they're somewhat valid. So what I'm doing is I'm repeating each experiment. So each time I make a change, that's a variant in the formula, and I'm making sure that I'm repeating the experiment the same way time after time until I get enough data that I can derive a statistically significant result. And in terms of statistics, I am using the Shapiro-Wilk test of normalcy. So what we're trying to get, when you repeat the same thing over and over again, you're going to get a range of results, and that's okay, that is normal. But in order to make sure that the biggest and the smallest and the middle are evenly distributed, we have to put them through a statistical analysis, and that's what I've been doing. So I found that I have needed to repeat the experiments anywhere between, I think it's about 20 and 60 times, so some less than others, depending on the potential for variability. And after doing the test that many times, I get some data that is then recording a statistically significant result. So the findings that I've got so far about the cardboard, metal, glass and plastic, these are statistically significant results. There's definitely something going on, but it may be that there's other factors that I need to consider which are magnifying the result a little bit. So for example, in the glass, I'm considering whether the glass slip is having an effect, whether there's a friction that's coming into play that's reducing the pressure. And with the plastic, maybe it's the opposite. It's a smooth surface, but maybe it's got good grip of the balm and it's kind of resisting the and actually pushing back more. And with the cardboard and the metal, very different again, but maybe their differences in material is sort of, you know, evening out a bit, so they're behaving very similarly. Anyway, that's what I'm going to talk to some packaging experts about. Science is often a collaborative affair, so I'm going to do that. I'm going to get my force meter calibrated just so that I can make sure that that's all good, and then, weirdly enough, I'm going to come back and do all of this testing again, in ironing out any of the other little variables that I can think of, so that I can get the proper set of data that I can then present in paper form at a scientific event, should I wish to. Thank you.